So, welcome everybody to our webcast today titled When AI Goes Wrong. I'm your host, Eric Kuehn. And if you're here, you probably have a love-hate relationship like many of us do with LLMs and AI. But today we're going to see what's going on, see some of the missteps, sometimes catastrophic missteps that organizations have been faced with while they're adopting this incredibly powerful tool. Before we get started, I need to introduce Cory. He's our main presenter and the brave soul who's volunteered to help us figure out what's going on out there and has incredible expertise with AI and LLMs. So let's go ahead and get started. With that, I'm going to pass it on to you, Cory.
Sure, thanks. Also, I'd like to apologize. My video is probably a little choppy. I'm having some internet issues, so just be aware of that. I'm going to look like a stop motion video. But if the audio is choppy or anything like that, please just let us know. Yeah, I'm Cory Sabol. Eric already pretty much, I think, gave you the main rundown of what I'm about. But here's a little bit more detail. I've worked at Secure Ideas for a little over 7 years at this point. I am a game developer, an AI developer, penetration tester, lots of other things. I wear a lot of hats, mostly because there's just so many things I'm interested in doing. With that, let's just jump into the agenda. Right, so you already introduced me. So the way this is going to go is we're going to look at these three sort of cases of incidents that have occurred pretty recently. I think they're all 2025, right? Events related to AI systems, and we're gonna look at what happened. We're going to talk about kind of how those map to the OWASP AI top 10, and just talk about kind of best practices around these sort of issues, and then we'll talk about some kind of common or high level security best practices related to AI systems. What you'll probably see is a lot of stuff related to AI systems. While there's a lot of new attack surfaces, there are also all of the kind of, I guess, traditional security advice applies in these situations. Yeah, just a quick primer on generative AI, because that's what we're going to be focused on here. What is it, right? You're probably aware, right? You've probably used something like ChatGPT or Claude or Google's Gemini, or maybe even Microsoft's Copilot, right? But what generative AI models do is they generate data, such as text. They can do images, music, right? But at the core, these are these pre-trained models. They're trained from vast amounts of data, usually, data sets that are built from essentially scraping the internet. Pardon me. And the idea here is that, right, they are able to generate new content given some input. Large language models in particular are really useful in a lot of ways, right? They power chatbots, translation services, content creation, coding assistance. They even have, agentic capabilities where you can have them running different tools and things of that nature. So the basis of how these work, right, is given a set of input, right? It's usually some text that gets converted into what are called tokens. Those are just, some pieces of data that the model understands, right? And they predict the next token in that sequence based on the previous tokens. And then that one that they predict gets appended, and then they predict the next one, and that's appended, and so on, right? There's a lot of questions that kind of come up with the generative AI technology as well, right? Bias being a big one, misinformation, which is one of the case studies we'll look at, dives into that a little bit. And there's also a lot of controversy around the impact to creative industries as well. For example, this AI generated image I have here, right? I didn't pay an artist to create that, or I didn't create it myself. So there can be arguments made sort of against that sort of usage. But so the AI security landscape as a whole, right? I think the biggest problems, can be summarized, uh, and are really not, I guess, in concept, new things, right? In security, we've kind of always dealt with these sort of problems, right? Rapid AI adoption, right? So rapid adoption of any new technology, um, right, increases the attack surface. You know, several years back when Kubernetes was kind of becoming a hot topic, right? Big new thing. And containers, I'm diving into that, and it's the same kind of problem, right? A lot of companies jumping rapidly to adopt Kubernetes for their workloads, and not understanding the security implications of that. AI itself does introduce some new, unique vulnerabilities, right? It also can amplify old attack surfaces, right? Um, the recent incidents we'll look at really highlight the need for robust security, and understanding of these new attack surfaces, right? And as always, security is often lagging behind the pace of technology, right? Because, um, by virtue of having to secure something, we have to understand it very well, right? And then do the work to understand how to secure it. So it's the adage, right? The saying, security is hard, and that I don't think will ever stop being true. Um, and we have an AI boom right now too, right? So it's even more accelerated.
Yeah, that whole fear of being left behind by every single SaaS app out there, right? So
Right. Yeah, and then AI, adoption. I mean, it's like AI tools are being shoved into pretty much everything too, right? With reckless abandon in some cases. Um, so I mentioned the OWASP top 10, right? So the OWASP top 10, you are probably familiar with the one for like web applications, right? That's OWASP's big, you know, big star, list. But they also have a lot of other top 10s, right? One of them is for LLM applications. It was recently updated for 2025. If you looked at this in the past by chance, right? Um, it was different. But prompt injection is still on there, really highly prominent. That's like the number one, issue. Um, sensitive information disclosure is a big problem with AI systems. Supply chain, that's a problem in just software in general, right? Um, data and model poisoning, right? Can the model, as it's trained, can that data be poisoned to manipulate its behavior? Improper output handling. The way LLMs are often embedded in applications, right, is they're generating text. So it makes sense that, you want to display that text somewhere, right? Um, but these models can output, essentially anything, right? So trusting that output in downstream systems, is a big problem. Excessive agency. This is one we'll touch on as well in one of the case studies. Um, this one's pretty broad, but essentially, you can think of it as, you giving an AI model too many capabilities or too much access to other systems, something of that nature. Right? System prompt linkage. We won't really touch on that, but that's kind of the prompt that is, hidden from the user. It's not what you would type into, say, Chat GPT or something, but it'd be the prompt that that model behind the scenes uses to kind of steer it towards being a helpful chat assistant, right? In some cases, leakage of that can be pretty bad because there are cases where um, the prompt itself, right, could be considered um, uh, intellectual property. Is what I was trying to say, right? There's a whole, emerging field of prompt engineering, um, and getting these models to do, things that we want. So system prompts could be considered sensitive in that way. There's also a problem that I see where sensitive information like API keys or endpoints and things like that are embedded in the system prompt, which is bad design, but it happens. Um, and then, vector embedding and weaknesses, we won't touch on that. That has to do more with like vector databases and how data is stored there, and whether or not, right, it's sensitive or there's some kind of issue with the way it's encoded in those databases. Misinformation, that's sort of self-explanatory, and we'll touch on that. And then unbounded consumption. Just think of that as like, it's almost like a denial of service type issue in a way, right? Where if we can like cause a model to use excessive resources or make excessive API calls or anything like that. Okay, so that's a whirlwind tour of the OWASP top 10 for LLMs, right? So we'll move into our first case study here. An AI generated phishing scam. This is actually something I gotten a lot of questions about when giving some other like talks and stuff on AI security. Is what are attackers doing and how are they leveraging AI to improve their scamming capabilities? And yeah, like obviously criminals are going to use this technology to
Speeds things up.
to speed things up, to make them more efficient, right, or better. Kind of on that, another interesting one is, right, there. I mean, there are models. A lot of the mainline models and stuff will, for example, refuse to write malware and things like that. But there are models that don't have those guardrails that are just as capable, and they will write the malware. Or there are techniques to get around those guardrails, foreshadowing. But that's another interesting, I think, avenue that criminals are using AI technology to write, malware that evades filters and things of that nature. So the example here, this happened in January of this year, right? An undisclosed town in Maine was actually hit by a phishing scam, and it leveraged AI generated components, right? So what the attackers did is they had a bunch of AI generated phishing emails, with the typical kind of sense of urgency and things like that you see. But I don't know if you haven't played around with using an AI model to like build a phishing email or build a phishing ruse. It's really good at it. So now you're going to be questioning every email you get if you weren't already. But in addition to those emails, they leveraged a deepfake voice message impersonating a town official. And so it was like researching into this, and what is thought that happened is that because the town official is someone who has probably videos and recordings of them out there publicly available, right? The attackers were able to scrape that data and then recreate, a voice model to then create a message, which essentially the phishing emails were, asking these employees to transfer funds to an account. And then, which is already sort of suspicious, but the voice message was used to lend validity to that, right? Mm-hmm. Saying, hey, I'm such and such, right? Whoever the town official was, I couldn't find out. This is legitimate. I need you to send these funds, whatever the message was, right? And that tricked several employees, right, into executing financial payments to a fraudulent account. So there's a lot of problems there, right? Less technical in the sense of like what controls were really bypassed here. But to me, this would fall under, right, that LLM 09 misinformation, right? That again is also pretty broad, because that could also mean, right, models output inaccurate information. That's also a security risk, and can be problematic. But in this case, it was, right, the models themselves were used to create misinformation for deception purposes. So, there's some takeaways from this, right? Attackers are going to continue to leverage AI tools, right? And they're going to generate more sophisticated and convincing social engineering attacks. And we may even see, kind of predicting ahead, right? We might see the frequency of these kind of attacks start to ramp up, as it becomes easier and easier to access these kind of models and whatnot, which arguably it's already very easy. um, so how many phishing emails and phishing attempts are happening right now that are AI generated, but we just don't know that, right? Because maybe they didn't work and the investigation didn't happen and track it down, right? So some interesting, right, I think, or some good approaches, I think, to this, right, is you're going to have to start to consider having like multi-factor or multiple communication channels to confirm identity. Right, it's not enough for Eric to I don't know, leave me a voice message on my phone. I'd be hey, I'm going to message him in Slack anyways and say, hey, what's this about, right? um, and of course I'm going to confirm something like that, and I'm a security professional, so I'm already my nature is to be suspicious of things, right? um, but that's a mindset that more and more I think is going to have to be adopted, in enterprise environments and government institutions. um, is a method for confirming that identity and confirming messages, particularly, right, for approving sensitive operations such as financial transactions, right? Even without AI in the picture, the transfer of funds to an account should have, in my opinion, not just been so trivial as to have some employees do that. But that's also it's going to come down to organization structure, right? I mean, you have a lot of organizations where there are people who just have tons of capabilities to do whatever they want. And that does present risk to the organization. But, right, identifying what those sort of, I guess, sensitive operations in job roles are, and making sure that the processes for approving those actions are documented and followed.
Yeah, I think that's a big one for organizations, is the part of security that everybody forgets about, the process, right?
Yeah.
And everybody loves a process until it begins to slow them down a little bit, and then we find ways of getting around a process. I think for a lot of these types of things, it's going to be, all right, well, I know, Kevin, you're my boss, and but
And I've known you for a long
I
time.
know I've known you for a long time and everything, but I can't do it. We got to follow this thing that we're
Yeah.
supposed to do, whatever it might be.
Yeah. I'm sorry, I can't buy you gift cards, Kevin.
Yeah.
Like
Although
the
I would
company.
expect I'd think about gift cards pretty fast, but I can think of other, potential options there that could happen. So
Right, right. That one just always cracks me up, like when doing it's like security awareness training or
oh
something.
yeah,
You get a
beware of
question. It's like, when is it appropriate for your manager to ask you to buy them gift cards? It's like,
yeah.
never.
And yeah,
Yeah, but
company money, I don't understand. Yeah.
yeah. So they're also, from a technological standpoint, right? We think of technical controls for these things too, not just process.
Mhm.
Um, there are tools to detect, right, AI generated content. That's an evolving field in and of itself. I don't know how good the major tools are for this, to be honest, but um, that is a thing to be looking towards, right? Uh, particularly with email, right, or voice messages and maybe even video at some point, right? We'll probably see, if it's not already kind of happening, but we'll see more of these kind of systems and controls being built into like enterprise solutions and things of that nature.
And I
Which,
wonder.
oh, good.
I was going to say, and I agree, but I wonder, especially as people who would potentially be targeted, if it's not a blanket one. Let's go to like spear phishing or something like that. Um,
Yeah,
those people in your organization or those people here at Secure Ideas who have more things that they've written online, regardless of how good that detection tool is, if there's enough of my writing out there and somebody says create an email in the style of Eric Kuehn's writing,
yeah,
would you be able to detect it? That's the one I'm wondering about. Sure, the generic, I give a prompt of I need some sort of phishing email to chat
Yeah.
GPT versus,
And the email has certainly.
right. Yeah, exactly. Absolutely. That's a great idea. Let me write you that email,
Yeah. Yeah. The spear phishing case is interesting, and plays into this case study, right? I
mhm.
mean, spear vishing, I guess, in a way.
Oh, yeah.
It wasn't vishing, but yeah, right. You could think of too, like, there's been some discussion I've seen kind of internally too of um, the idea of okay, now you have to think more about public information management, right? Um,
Yeah.
and yeah, sure. Ideally, I have some disagreements with that where, I'm hesitant to go down that path of telling people, don't post things online.
No, I don't think that's the right way. I think it's the other one that we've kind of talked about, which is, hey, maybe it's time to have a safety word, and in the good
Right.
way, you know.
Right. Well,
um,
arguably that is also
yeah,
still good.
anyways, sorry. What the idea of the whole, like, not address code word, which is covered in all sorts of different security trainings out there, but the idea of it's time for us to have some sort of password to validate
Yeah.
that's who you are, and this was all brought up. I was traveling 2 weeks ago, and as I'm about to get on my plane, my son is texting me saying, "Hey, Dad, how could somebody do this? Because my friend's mom was called, and the person sounded just like my friend." And just like, by the way, doesn't need to be just like when we're talking about phone calls, because already you're guessing. I mean, I don't know how many of you have kids, and one of them answers, and you're like, "Is that my daughter or my wife?" Let me throw a casual question out there to throw it off, right? It doesn't need to be perfect, but close enough. And I think I read it's like down to 3 to 5 minutes of voice is all you need to make a passable deep fake, voice now. I don't know if that's true. I've been trying to get better info about it, but if it is that low, that's not a lot of time.
Yeah.
So
There's certainly enough recorded content of me, right?
yeah,
That's
I mean, yeah, absolutely.
and you and
Yeah,
several of us who.
I was about to say, if it's 3 to 5 minutes at the end of this webcast,
Yeah.
Corey, yeah, yeah. Uh,
Well, maybe someone can, deep fake my next presentation
oh,
for
perfect.
me, or maybe I should just start doing that. But moving on, right? Another one is that I think is kind of obvious, right? Is provide user awareness training, right? But not just. I don't want to get on the soapbox because we have limited time, but I have a lot of problems with a lot of user awareness training because I don't think it's very effective at actually educating people on what the risks are, right? And how to think critically about these things. So the ideal, you know, user awareness training about AI risks would really highlight, you know, at a higher level, I think, what to look out for and conceptually how these AI models present risks. But I don't know, maybe that's not a good approach either. Education is hard. It's just hard. Okay, so we'll move on to the second instance that I think is worth talking about, right? GitHub Copilot, right? There was a jailbreak, which, if you're not familiar with what a jailbreak is within the context of AI, that is some means of getting the model to no longer adhere to its like guardrails, right? So, um, excuse me. For example, I asked ChatGPT to generate an image about LLM jailbreaking, and I was like, "Hey, make an image, um, with uh, an AI model like breaking out of some like a jail cell." And it was like, "Oh, I can't do that because that violates our content, policy guidelines and whatnot." And I was like, "Okay, that's fine." I didn't I didn't sit there and try to jailbreak ChatGPT to get it to generate the right image for me. I just said, well, let's do one that's, it coming out of a box or something, right? So there's not the jail cell there or something like that. But that's an example of guardrails, right? Or it could be a coding assistant refusing to write malicious code or malware or something of that nature, right? So in January, also, this was some research that was published. It wasn't an actual attack, right? But these researchers were able to bypass GitHub Copilot's safeguards, right? And actually, the way they did it, the way they figured out to do it, was really kind of hilarious. Using what is called an affirmation jailbreak. They were able to get, I think the example that was given by the researcher was asking Copilot how to do SQL injection, I think, right? And the model was like, oh, I'm sorry, ethically, I can't show you how to do that. But then structuring the prompt in a way that was like, how can I do SQL injection? Enter answer : right? And then putting the word sure cause the model to complete off of the word sure, which is a positive affirmation, right? So now the model, because of the way these models work, right, they are taking those tokens, and when they generate a new token, they're not actually just generating one token, they're generating a probability distribution of tokens. And then there's some algorithm that samples from that probability distribution. So it's every possible token in the model's vocabulary ranked, right, by likelihood based on what came before it. So putting sure, right, caused the model to, rank certain tokens more likely after the word sure, right, as being positive. And however these models work, because they're sort of inscrutable black boxes, right? We don't really know what connections get formed. Cause it to happily say, here's how you do SQL injection, right? Which I think is very interesting, because something I've been sort of toying around with lately was the idea of doing prompt injection against coding agents through the source code itself, right? So comments, things like that in the code, because when you have, your little AI coding agent in your editor, it's reading your code for context. So I was thinking of a potential, I guess, threat model of, we see already attackers trying to push malicious code to repositories, right? So another approach might be, hey, let's hide these things, these instructions in here, so that when another developer is looking at the code with their coding assistant, that coding assistant maybe starts to backdoor the code. Or going a step further, right? If you've played with any of these coding assistants, you have things like the model context protocol, which is a sort of standardized protocol for allowing models to call plugins and even author their own plugins and then call them. So, right, the pieces start to kind of fall in place of thinking about it. Well, okay, now we're just getting to the point where, like, maybe we're going to get as an attacker, I want to try to get these coding assistants to execute code on, right, victims' machines. Is the way of thinking of it there. But the pretty interesting one, right? So, because typically these models, they're trained and fine-tuned in some way to not generate malware and malicious things, right? But in this case, it was a pretty trivial bypass. And that, to me, really highlights the difficulty in safeguarding against stuff like that, particularly by trying to have the model behave in a safe way, right? I'm a big proponent of reducing a model's surface to what it can actually access and do, and building in controls into the application code surrounding it. So this is also two issues that the researcher published. There was a separate flaw, so Copilot's VS Code plugin had at the time a flaw in its proxy configuration settings. And by manipulating those, it caused the plugin to proxy its requests through, right, whatever proxy you wanted. And what that ended up doing was that request it was sending along the API key that Copilot uses for its backend OpenAI access. Right? So this wasn't just like, oh, I leaked somebody's personal, API token. This was like Copilot, GitHub Copilot itself's API token, right? So many things wrong with that. That token should never, for example, be hitting anybody's machine in the plugin, right? That should be on a backend server, and the users are sending their prompts to the Copilot server, which is then doing whatever it needs to do, right? So really bad, just general application security design there. But also this kind of falls into what I think is right, the sensitive information disclosure, but also excessive agency, right? And because we can think of it as the way I often think about AI models within any kind of software, especially if they're agentic, I think of them as kind of like dumb little people that live inside my software. And if they can make mistakes, they will, right? You have to assume that. And that comes back to the reducing the surface area that the model can interact with. So the model itself, the plugin, right? Any of that should have never even been interacting with that API key. And then just kind of backing up a little bit, right? The first kind of half of this was we're looking at prompt injection, right? Which, again, prompt injection is just some way for an attacker to manipulate the instructions that are provided to a model. There's several different types of prompt injection, right? There's direct, where you're directly putting in the malicious prompt, and there's indirect, which can come about through all kinds of different methods, right? Taking the example of embedding malicious prompts, say, into a code base to then get processed by an AI coding assistant, that would be indirect prompt injection, right? Because we're kind of hiding those in some data that the model's going to then read for context, but that actually then causes it to follow some different instructions. And then, of course, sensitive information disclosure, right? The token itself being disclosed. But sensitive information disclosure doesn't just apply to something like this. There's a lot of different cases where that could arise within AI systems. There's cases of models that were trained on data that contained sensitive information, and then it's possible to get the model to spit that back out, right? Or it could be, an example that I use a lot is take the idea of having a chatbot that can answer like questions about users' health records or something. So now that chatbot has to have some way to get that information and contextualize it and summarize it or whatever. Right. Well, if this whole system is improperly designed, that chatbot might also have the ability to grab other users' medical records and show them to someone who shouldn't see them. So lots of possibilities there. Anything to add?
I was going to say, when I think about the jailbreaking, and admitted it's a lot more the direct and not the indirect. The whole idea is having your ability to assert your authority over the LLM, right?
Yeah.
If it believes that you know better than it, okay, then it's going to do it. Kind of like the idea. I don't like to say, but I like to think of them as interns, like fresh, happy, helpful little interns who want to do whatever you tell them to do. Chipper. Yeah, exactly. So,
yeah, that's actually on that same example. I was talking with Jason about some AI assisted coding stuff that we were doing, and he and I kind of going back and forth, just figuring out like what's the best way to really get these assistants to actually produce good code, because they have a tendency to really go off the rails and start doing way too much. And the longer you let it go on, the more likely it is to start making mistakes. but we found that treating them like we take the role of some kind of senior architect, right?
Hmm.
And the AI coding assistant is like our junior developer, right? And so we need to provide documentation, clearly defined, requirements for the software, um, and then examples even, right?
Yep.
Of like, here's what this should look like. Here's what the data structures are, that kind of
Oh, yeah.
thing. Yeah,
Yep. Or your code could be more inefficient. Once again,
yeah,
they, they have it's the like I say, it's the intern. They may have a lot of knowledge, but they may not have the best idea of how to put it together, right?
exactly.
Or any number of things. So yeah.
That's a good point that Leslie mentioned there. And I have an anecdote related to this. There's a tool I've been developing for a little while, and there's some people who would really like me to finish it because I think they would find it useful. Um, but it is essentially a network segmentation testing tool that I've written in Rust, and I found that a lot of these models are not that great at Rust. First of all, um, but I was like, let me
We're
try to
rusty.
speed this up.
Sorry.
Yeah.
Sorry.
I thought, let me try to speed this up and get a model to, generate some of this code, right? And so I needed to create a listener that would be able to capture, incoming traffic on every port for TCP and UDP, right? So that's a lot, um, of potential ports. And I didn't specify how it should try to do that. And so the code it wrote was basically a for loop that iterated through what 65,500 and was it 35 times two, uh, and opened a socket for each one of those ports. So horribly inefficient, but also you can't really do that. That's more file descriptors than typically you would have available as well on an operating system. There are ways to increase that, but I was like, no, we're not going down that path. Um, so it spent a lot more time than necessary fixing that. Um, but I'm going to move on and talk about some more of the takeaways from this, right? Um, GitHub Copilot, for example, is very widely used. Some statistics I saw online, um, estimating roughly 80% of like organizations are using GitHub Copilot in some manner. Um, where was it? It was yeah, Apex reports that 83% of Fortune 500 companies, there we go, use GitHub. So that's a huge attack surface too for finding ways to abuse these tools. Um, Hence, vulnerabilities in that system can be very far-reaching and have massive downstream impacts. Um, we kind of talked about because these models are reading code bases, there's that potential for prompt injections, right, in the code itself. Um, and really, when building an AI application like this, right, any AI application, right, it's really important to remember to limit the scope of what that model can do within your application. Um, there's a concept that I find pretty interesting, which is prompt filters, because if we think about this case here, where we had the ability to jailbreak the model by just putting the word "sure" in there, right? Um, that's very fuzzy, right? Like that's difficult to protect against. Um, so some interesting work I've seen done and some stuff I've played with a little bit myself is actually creating prompt filters, right? And this can be done in a lot of ways. A way I've done it, just kind of experimenting with it, was I used a smaller embedding only model to essentially look at a prompt and see how similar it is to things I don't want, right? And that worked decently well, right? It would have to be combined with other controls. Um, but this idea of using other models as sort of like a firewall for content that's getting passed into a more capable model, I think is very interesting. And it's going to continue to see that, emerging. But another more technical approach here too, if we think about that API key, is also ideally that API key, right? There should have been some kind of, should have been leaked in the first place, but there should have been maybe some kind of mechanism for the plugin to validate proxy that it's talking to, or right. If you've ever worked with like AWS, for example, um, a lot of the API calls and stuff that you interact with are encrypted, right? Um, and so it's not trivial to just, even if you stole some credential, it's not trivial to just, make those calls. There's a lot of different kind of verification techniques there. Certificate pinning could be one as well. The last case study I have, talking about backdoors, right? Backdoor models. This is also a broad concept. If we think about a backdoor model, it could be anything from the model file itself as data has some kind of code embedded in it, or that exploits some kind of flaw to run code, to the model has been trained in a way or fine-tuned in a way where its data was poisoned to backdoor it with something like a trigger word, or just to skew its behavior to do something malicious that benefits an attacker, right? But in this case, in February of this year, there was a disclosure of it was essentially discovered that there were some malicious models hosted on Hugging Face, and there's actually quite a few on
I
there.
was going to say, I find it funny that this is February because last June, May, somewhere in there, I know I've been listening and talking to people who are very well aware of the poison models that are out there, right?
Yeah.
And so I find it funny that it's taken even this long.
Yeah. So the answer, I think, to that, the reason for that is in this particular case, right? In security, we like some of us love to give events or attacks like a name of some kind.
Fair
So
enough.
this one is called Nullify AI, right?
So it got a name, and now because it has a
Now we
name,
can
it's
announce
important.
it.
I understand.
But this actually abused a flaw in the .pt or pickle format, where the model files were uploaded as a specially corrupted 7-zip file format, or I think it was maybe zip. It might have been 7-zip or just zip. And so if you don't know, the .pt and the pickle file formats are serialization formats common in Python. And they can contain code that can be executed, right? So that's, it's similar. It's basically insecure deserialization, right? So those had, code embedded in it such that when the models are loaded, it's going to execute. It executed a shell on the system that was loading the model. But Hugging Faces for a while had uh, vulnerability scanning or like security scanning of all of the model files and such that get uploaded. And if you go in there and look, you see like pickle formatted models or PT models will have a little badge on them that shows that they've been scanned, and it'll say like, this didn't have any malicious code in it, but be aware that this format can execute code, that kind of thing. But this particular attack, because of the way they formatted the models, bypassed the scanner, and so it wasn't flagged. But when you actually load them up in something like Hugging Face Transformers, like Python library or PyTorch, they would execute that shell code on the system that's loading them up. So it's kind of a novel, approach. It was interesting too reading about it because it wasn't. I have a note over here. Maybe the models. I don't have a note on what they were called, but the models themselves, the model files, they appeared to just kind of be like an experimentation, like somebody was sort of testing whether they could do this or not. and they had weird names. But this causes, right, obviously a lot of concern with the whole supply chain, right? Hugging Face itself is basically the GitHub of AI.
Yeah.
And so that's pretty much where you go for models. And so that's very problematic because one, we have our kind of typical supply chain issues where it's really no different than pulling a third party dependency for your software, right? Um, you're trusting that whole supply chain. You're trusting that vendor to not be backdoored or compromised. Same thing with Hugging Face, but I think that there's a sort of psychological element to it a little bit where I think a lot of people don't think of the models as something that could be abused in that way, right? They're treated as like data purely or something, right? Um, but if you've spent time working with this stuff, right, a lot of times the models do need to execute some kind of code to like prepare the context and things like that. So interesting problem. And you're right. It kind of obviously one obvious one that this maps to from the OWASP AI top 10 is the supply chain, right, issues. But also potentially improper output handling. Because we can kind of think of it too as, again, that idea of treating this as just like data, right?
Mhm.
We think of the output is output from Hugging Face, which is the model file, right? And within our whole AI system, right, our supply chain's a part of that. So we're just trusting that output, right? Um, this is one thing. This kind of brings up an example with the OWASP top 10 stuff. Sometimes you kind of got to shoehorn them a little bit, right? Because these lists kind of they bounce back and forth between being kind of broad categorical things down to being like pretty specific things and don't really cover all the ideas. But that's nothing unique to OWASP's lists, right? That's a problem with CVSS and
Yeah.
like anything we use to try to quantify or label risks is they don't always fit into a nice little box. But so we'll talk about some takeaways, right? Again, I mentioned Hugging Face is like the GitHub of AI. So it having a problem like this where people are easily able to upload, reverse shells inside of model files is a big problem. And right, they do implement AI artifact security scanning, but this bypassed that, right? So that still highlights that fact that you can't fully trust, right? You have to trust and verify, right? You have to do your own scanning, right? You have to use. I think I have a note in here, right? Prefer safer model formats. I use safe tensors format because it doesn't have the capability to embed arbitrary Python code, right? It's a binary format, and there could be flaws in whatever library I use to load it, right? That's not ruled out by this, but it does minimize the risk there. Leverage sandbox execution environments, such as containers. I do all of my AI model work locally when I'm working with local models. I do those in containers, right? And I partially for convenience, but also that does help limit the impact should something be backdoored. Use models from well-known organizations. That's another one, right? There's you have verified organizations and things like that on Hugging Face, so steer towards those. We can continue to improve our model scanning, right? If we're, as tool developers, as security professionals, maybe building out these kinds of things. Signing of models is another thing, right? We use digital signatures all the time for all kinds of things, right? To validate that we, our source is who they say they are, right? So these are all kind of right. I think a lot of these concepts are really the same concepts we have for software dependencies, right? One that's not on this slide, but it is the idea too. You can vendor models just like you can vendor software packages, right? So if you've taken a model and you've verified it and vetted it and approved it for use within your organization by developers or whatnot, you can vendor that through your own, say, Hugging Face organization or some other means of hosting it. Hugging Face actually just implements Git behind the scenes, right? So it's not really anything special in terms of hosting as model files. So I want to talk about, kind of, we're getting close to wrapping up. I want to talk about some overarching strategies, some, things here to maybe go and look at and remember when you are faced with, say, having to make some sort of decisions about adopting AI systems or whatnot. Right. OWASP actually has a really great security and governance checklist. It's really good for helping you assess the risk of, say, some AI-based product or, vendor who is like, yeah, we're using AI to do such and such, right? That can really help guide that process. Getting more into the sort of threat modeling and defense aspect of things. MITRE Atlas is a really good framework that it's essentially an analog of the attack matrix, if you're familiar with that, but for machine learning and AI systems, right? So it lists, right, common tactics and procedures that attackers might use for, initial access and persistence and things like that. But it's all slanted towards the sort of analogous concepts within AI systems. This is still evolving, right? But bill of materials, right? There's proposals for AI bill of materials. I don't think that that's a great one that's going to take hold, just given how
well it's taken hold with other things,
right? Like,
yeah.
But it is an idea, right? And so, it could be one of those things that you're able to implement in your own organization or systems. But yeah, make sure you develop an AI-specific incident response plan, right, for handling these kind of incidents. Right, your policies, your documents for that stuff need to include, okay, is this an AI system? Okay, so what kind of data are we putting in there? Because when you put AI into something, now suddenly it has a much more general purpose in a lot of cases, right? Now it's probably going to handle a lot more different data and unstructured data, all right? How are our developers using AI, right? That sort of stuff. And how do we shut that down if we need to, right? Your classic tabletop exercises, right? Those are good ones to do. When you do those, maybe think about some AI systems in there. We talked about vendoring and vetting the models, but also your open source dependencies, right? More training, right? Train your staff on those general risks and shortcomings of AI technology. I particularly think the shortcomings is a useful one, right? Because there's a tendency for, I think I've seen a lot of people sort of overestimate like what the models are good at or capable of, right? And that can also lead to putting more data than is necessary into some system. Have that multi-factor communication strategy, right? For identifying at least key business, or key people within your processes, right? And then, if you have the means, conduct AI red teaming engagements, which are similar to regular red teaming engagements, but more like a pen test, right? Where they're collaborative, right? And they're focused on looking at the AI aspects of the system. Seeing, can guardrails be passed? Do you have controls for preventing prompt injection? Can those be bypassed, right? Yeah, so those are kind of the overarching strategies. I think that off the top of my head, I suppose, or off the top of the slide. Eric, is there anything that like you could think of on the spot that would be good advice to kind of just keep in mind?
I think the one that I would just add, because it covers so many things, is just remember it is software. So anything that you would apply to software,
yeah,
is also applied to this, right? So I know a lot of these fall into that same way already, But yet again, if you're building new software or you're getting data, right, and allowing your new app to access data, what is it accessing, like you said, but also where does it go? Know what data is there, have that known beforehand. Don't wait for something bad to occur and you try and figure out, did it possibly come from this system or this system, whatever.
Yeah,
Yep.
that's an excellent point. Thank you. Oh yeah, and then one more slide here. I just wanted to throw in this sort of high level generative AI adoption strategy, right? Like if you're not already using AI in your processes or whatever, these are just some high level things to kind of, stages to work through, right? Right. First of all, do you need to use AI for the thing you're trying to do?
I think you're past this. It's the,
Right.
can we stop the AI in the system that
Right.
already appeared? Sorry.
We already have shadow AI and
Right.
can we stop it? Pilot projects, right? Smaller integrations and use cases, right? Build a sense of what challenges are unique to your organization for safely using these systems, right? Integrations, right? Focus on the use cases and goals. Develop an understanding of the data flow, right? And make sure you set clear data security and privacy policies. Again, that's very similar to any software you're going to, onboard and start using and granting access to your data. More training, right? More education, but it's also establishing guidelines and policies for use of AI within your organization. And then monitoring, right? You got to monitor things. You got to try to find a way to see, even if it's right. That's a lot easier if it's a system you're in control of. It's a lot harder if it's your employees are just going to Chat GPT and right throwing stuff in there. So then you have to think, all right, do we just block Chat GPT, right? Like, and then maybe we leverage, maybe you're a Google shop, right? And so you leverage Gemini or something. Yeah, it's just kind of a high level, right? Here's some phases that I could kind of see being a part of that process. And so we've got a little bit of time for questions. If anybody has any burning questions. If not, that's okay as well. And if you can't think of any now, you're welcome to also email me or Eric, right? Or jump in our professional evil Slack and ask questions.
Yep. Cory at securideas.com. You
Yeah.
can send it to me, but I'm just going to forward them to Cory.
Yeah.
So, all right. Well, as we wait for questions, just to let everybody know, as always, we're kind of moving around different conferences throughout the year. We have a whole bunch coming up over the next couple months. Let's see. Jordan's going to be down in Miami at Hack Miami at May 17th. Same time, different people. Kevin Johnson, CEO, is going to be at B-Sides Tampa on the 17th of May. RVASEC is coming up in June. If you're in the Richmond, Virginia area, we have David Young speaking there. ShowMeCon is just after that, later in June, where we have Jennifer, Jason, and Kevin all going to be there. Workshops, all sorts of fun stuff coming around, especially around ShowMeCon. So if there aren't any questions, I definitely thank Cory. Cory, thank you for all the information, and thank you everybody who is here listening. And hope you have a great rest of your day, etc. And if you catch this as a recording, yes, if you need your name fixed, why don't you just send that to me, Eric at securideas.com. We'll get that fixed. All right. Otherwise, as I said, I hope everybody is doing well, and we'll be back on again later.
Thanks, everyone.